Alright, so in this video we're going to learn, or just focus on isosceles and equilateral triangles. So remember, isosceles means down here that two sides are the same, and over here that all three sides are the same length. To your directives that you can state the relationship of angles and sides. In an isosceles triangle, we're going to learn about a very important theorem. This is going to also relate to what we did in class the day before, so if you're watching this video ahead of time, it may not make as much sense as if you would do the activities. So it might not be a bad idea to go back and rewatch it after you do this activity. So let's review. So in the activity, you learn that the side let me restate that. You learned in that activity that the biggest side is opposite the biggest angle. And I can say the smallest, the biggest side, is opposite of the biggest angle. So, if we look, here is my biggest side, which means this is my biggest angle. So if we have our smallest angle, which is here, which makes this the smallest side. We did that in class, so if you're watching this video ahead of time, you may have not known that already. But you will know that, you'll learn that soon. So we're going to use this fact when we're doing isosceles and equilateral triangles. So what if two angles are congruent? So they are the same. So if this angle and this angle. Well, then the opposite sides have to be the same length, because not one's bigger than the other. And what if I have two sides the same? Well, that means these two angles also have to be the same. The angles are opposite. Well, notice both of these are isosceles triangles. So let me show you a sketch pad, just so make sure to convince you. So right here I have an isosceles triangle. This length and this length, BC and BA, these lengths right here are the same. And notice, when I do that, angle BAC and angle BCA are also congruent. And then you have your other angle up here that is not. As I move this triangle around to change in my angles, notice my two sides stay the same, and then my two angles are also congruent. Alright. And then I can change my lengths. Alright. So I'm going to change my lengths, but my angles still stay the same. Alright. Now, while we're in here, let's look at an equilateral triangle where all three lengths are the same. Notice the angles. They are also congruent, because if all three sides are the same, well, that means all three angles are congruent. So this is an equilateral equiangular triangle. As I make my triangle big or small, notice they all stay the same. And the reason for that is that there's 180 degrees of the triangle, so if all three are the same, they all have to be 60, no matter what. So no matter what type of equilateral triangle you have, the angles are 60, which makes it equiangular. Alright, so let's go back to our slides. So in an isosceles triangle, which there's a very important theorem. Here we have something called a vertex angle. This is the angle that is not, this is not congruent. And then you have your base angles. These two are congruent. Alright, let's put the congruent sign down here. That makes this side and this side congruent. So if you have two sides the same, pretty much what the isosceles triangle theorem says, then two angles are the same. If two angles are the same, two sides are the same. If three angles are congruent, then three sides are congruent. It's a very important theorem. So we can use this to find the measure of angle X and angle Z. So here we have 50 degrees. Well, you know there's 180 degrees in a triangle, right? And notice you have two sides the same, which makes these two the same measure. Well, I already took up 50 degrees of the 180, so I can subtract 50, which gives me 130. Well then, if these two are the same, I can take that and divide that by 2. Well, 130 divided by 2 is 65. So both X and Z are 65 degrees. Alright, so down below we're going to do some algebra. So we're going to find the value of x and y. Well, notice I have two triangles. And I can, by looking at all three angles are the same, that tells me all these are the same length. So that tells me this is 4. Well, then also this is 4. Now here we have two angles the same, so that tells me this and this is also the same length. So this length has to equal 4. So I can set up the equation. It's a very short equation, and I bet a lot of you can do this in your head. X plus 1 equals 4 minus 1 minus 1, x equals 3. Alright, and then again we had y equal 4. Alright, one last one. So here I need to find the perimeter of the triangle. Perimeter is adding out the outside. We already have one length of 7, so I need to know the other two lengths. So here we have two angles the same. So that tells me these two sides are the same. So they are equal. So that allows me to set up the equation. I can go x sorry, I'm having technical difficulties here. Sorry, my writing thing isn't working. X plus 4 equals 4x plus 1. Alright, so that makes me, I can minus x here. So we're just going to solve this equation. So I get 4 equals 3x plus 1 minus 1, 3 equals 3x, divide by 3, x equals 1. So I got what x is, but I still need to answer the question to find the perimeter. So I need to know what each side. So if I put 1 in for x, this side is 5. If I put 1 here, well, these two are the same, so this also has to be 5. I kind of know I did it right. So to find the perimeter, I go 5 plus 5 plus 7. And that gives me 17 inches. Alright, to review, we have the isosceles triangle theorem, which is a biconditional, means it works both ways. If the two sides are the same, then the two angles are the same. If two angles are the same, the two sides are the same or congruent. And then if an equilateral triangle is also biconditional, if all three angles are the same, then that means all three sides are congruent. And remember, the angle measurement has to be 60 degrees in an equilateral triangle because 180 divided by 3 is 60, and I showed you that in Sketchpad. Reminder to do a reflection so you get credit for watching this video.